Hello, marvelous Algebra 1 students. I'm excited to have you here to help you review for your Topic 7 exam. Don't forget your Topic 7 exam is on factorable quadratics. We're also doing some polynomial operations, and we'll talk about that shortly. So, the first goal that's going to be on your test is you're going to be given various polynomials, and you're going to be asked to add, subtract, and multiply those. Really, adding and subtracting is just like combining like terms. Maybe there'll be some distributive property in there. And then multiplying is once we start to get into the box. We find that our students usually do really well on this first section, so pay close attention, and I think you'll feel very confident on the first part. So the very first thing you learned in this unit was how to add and subtract polynomials. And remember, polynomials are just all those terms put together, right? There's some coefficient times maybe x cubed, and something else times x squared, and something else times x, and so on and so forth, right? You have this whole list or this chain of terms here. Well, let's take a look at our first problem. Mrs. Galindo wants to ship several packages through UPS. The cost of shipping X, so there's no actual set cost of shipping, which makes sense because shipping costs change depending on the time of year, depending on how expensive gas is, so on and so forth. Depends on the size of the box you are shipping. That makes sense too, right? It costs more to send a larger box than a smaller. The cost for each size box is given below in terms of X. So to ship a small box, it's 3x minus 2, a medium box, and a large box. These are all in terms of x. We're not actually finding a specific value here. We're just leaving them in terms of x, which means x is going to be in our answer. Mrs. Galindo wants to ship 1 small box, 2 medium boxes, and 3 large boxes. And we want to know what is her price of shipping in terms of x, meaning x will be in our answer. And they also want our answer in standard form, right? That's when we put the largest exponent first, then the next largest, and so on and so forth. All right, well, let's handle the 3 highlighted pieces here, the 1 small box, 2 medium, and 3 large. Now, although what you could do is you could say, well, we're just going to write one of these out, and then we're going to write 2 of these, right? We'd write them out twice, and then you could write out 3 of these guys. That would probably take a little bit too long, and we know a faster way to do that. In particular, we know that we're doing 1 of these small boxes. Of in math very often means multiplication, right? So 1 of those, we know that there are going to be 2 of these medium boxes. And so instead of writing negative x squared plus 8x twice, I'm just putting a 2 out front. And 3 of these large boxes, 3x squared minus x minus 1. Once we know the price of each of our boxes, all we have to do is sum them or add them together to find the total cost of shipping. Before we add these together, we should probably drop those parentheses, and hopefully we know to drop parentheses we distribute. When you distribute a 1, it keeps everything the same. When you distribute a 2, we have to double our coefficients. Notice I'm not changing the exponents here. This exponent of a 2 will stay the same. This invisible 1 stays here as well. And then same thing for our last. We're dropping those parentheses by distributive property. Once we're here, we're pretty much done. We just need to collect or combine our like terms. We always start with the largest exponent first. The largest exponent I see here is a 2. This is a polynomial of degree 2. But there's 9x squareds and also negative 2x squareds. And if you have 9 of something and you take 2 of those away, I believe that will give us 7 of those x squareds. We're not changing the exponents. We're just counting how many we have. Next, I see some x's in here, and remember we can add or subtract in any order, so I could do 3 plus 16 minus 3. But what if I notice that we had 3 x's and we're taking 3 away? Don't those cancel out? Don't those become a 0? And it just leaves us with 16x? Right, 3 plus 16 is 19 minus 3 gets us back to 16. And then we have this minus 2 minus 3 more, which I think gives us minus 5. And we have our final answer, all like terms combined, written in standard form. And that's not bad at all, I hope. A little multiplication, and then we are adding and subtracting. All right, let's look at our second one. Given that f of x and g of x are these two equations, Mr. Sunday is asked to create h of x by performing the operation f of x minus g of x. So notice down here, right, he takes, let's say that this is f of x and this is g of x. He says, I want to make h of x, and he does that by doing f of x minus g of x, because they told him to do that. And it says he creates h of x below and writes his answer in standard form. However, he makes at least one mistake in his work. So we need to go down and figure out his mistake as we work through his terms down below. Well, the first thing he did, I love, he substituted the definition for f of x in parentheses, kept his minus, and then he substituted in g of x. Looks good so far. Once we're here, it looks like he dropped his parentheses, and then he rewrote all of his terms. So notice that he had like 1x cubed and minus 6x cubed. He put those next to each other. That's a cool strategy, right? Helps you see where your like terms are. And then he combined those. And in fact, looking at this, I see the mistake, and let's see if you can find it too. I think the mistake happens when he drops his parentheses, when he goes from step 2 to step 3. Can you see the issue? Well, what we did up here to drop the parentheses is we distributed the value outside the parentheses. So let's make sure Mr. Sunday did that correctly. I see, let's see, what numbers are hiding here? Well, I see an invisible 1 that's hiding out front here. So to drop these parentheses, we need to distribute that positive 1. But if you multiply by 1, nothing changes. So I think these 4 terms look awesome. However, I also notice that there is an invisible negative 1 in front of the next set. And when you distribute a negative 1, although it does keep the coefficient almost the same, don't forget that a negative acts as an opposite sign. So the opposite of positive 6 is negative 6, right? A negative times a positive is a negative. Or as we go through the rest, a negative times a positive should be a negative. A negative times a negative should be a positive, and a negative times a positive should be a negative. So I think his mistake is that he forgot to distribute the negative 1 to every term. He only did it to the first term. And so that means that his final answer is going to be wrong. Well, what does the final answer look like? Let's go ahead and write what he had. So the first terms were correct, right? He had 1x cubed, 2x squared, 7x, and 10. And the second one, though, should be minus 6x cubed minus 2x squared plus 13x minus 5. And now we combine those like terms. All right, well, I see 1x cubed over here. Do little triangles on these guys. Okay, 1 minus 6 of something is negative 5 of those x cubed. I see 2 of these x squareds, and we're taking 2 of them away. That's actually 0. So although you could write 0x squared, you're never going to see that on a test, because why write something if you don't have to? If there's 0 of it, there aren't any there. Then we have minus 7x and plus 13. I would think of that as 13 minus 7, which is 6 x's. And last but not least, I see 10 minus 5, which is 5. And now we have the correct simplified equation. That's all there really is to the first part of the test, adding and subtracting, not forgetting to distribute a negative. Let's get to the second part, multiplying polynomials. What's the product? And we need to know that product means multiply. What's the product of the two binomials? So we have a binomial, 2 terms, times another binomial, written in standard form. Well, there are 2 ways to do this, so I'll show you both ways. Many of my students prefer the box method. We need to remember that when you multiply polynomials, our factors, 2r minus 3 and r plus 3, go on the outside. 2r minus 3, r with a positive 3. They're like the length times the width, and when you are multiplying, you're finding areas. So 2r times r is 2r squared. 2r times 3 is 6r. r times negative 3 is negative 3r. Multiplication, negative 3 times 3 is negative 9. Now, you could have done that a separate way as well. You also might have learned that we can do this through distributive property, or the arrow method, or the rainbow method, or whatever your teacher might have called it. And so to do that, we multiply 2r times both the terms in the second set of parentheses. 2r times r is 2r squared. 2r times 3 is positive 6r. But then we also have to multiply the negative 3 times each term here. That's negative 3r minus 9. Notice that all the terms in here are the same as the terms in the box. It's just two different ways to do that. What do we have to do last? Oh yeah, combine like terms, whether you're going from here or from what's in the box. 2r squared, 6r minus 3r is positive 3r's, and minus 9. Whichever way you do it, notice these diagonals are the like terms that are right here. We should end up with the same answer. All right, problem 4. Given that p of x equals x minus 3 and q of x equals x cubed minus 6x plus 9, create t of x by finding the product, which we know means multiplication, of p of x and q of x. So what does that mean? Well, it tells us, right, that we can go through and say that t of x equals p of x times q of x. Of course, I wrote the letter p twice. There we go. Or we could say t of x equals, and we'll do some parentheses because we substitute p of x, and then another set of parentheses because we are going to substitute q of x. We know p of x is x minus 3, and we know that q of x is x cubed minus 6x plus 9. Once we're here, we actually have to multiply all this out. So although you could use the arrows, and there's nothing wrong with that, I'm going to arrange this in a box just because I think it's fairly useful for organization. So I'm going to go through, and I may have not given myself enough room here, but that's okay. We'll just write a little bit small. You'll notice that with this box, we have an x minus 3, so that's a partition or a single partition. We cut the box in half this way. But then with the x cubed minus 6x plus 9, there are 3 terms, so I need 3 open spaces on the top of the box. That gives us x cubed minus 6x plus 9. And now we find the insides. X times x cubed, well, there's 3 x's times 1 more x gives us 4 x's multiplying. X times negative 6x, negative 6x squared, positive 9x. Negative 3x cubed, positive 18x, watch that extra negative, and negative 27. So we have found that t of x equals, and we'll just write all these out, x to the 4th will go largest exponent to smallest exponent, minus 3x cubed, minus 6x squared. There's an 18x and a 9x, minus 27. Now hopefully you're saying, wait, shouldn't you have combined like terms? Yes, and if you already combined like terms, that's great. You don't need that last step. But yeah, we do need to realize that there are 2 like terms here. 18x plus 9 more x's gives us 27 of those x's. So hopefully you're starting to notice that when we add or subtract, we never change the power that's on the x's. The only time we change that power is if we multiply or divide. So if we're multiplying into a box, the power is going to change, but adding and subtracting it never changes. All right, let's look at 5. 4 expressions are shown below. Select and justify with work all of the expressions that are equivalent, fancy way to say equal, to negative x squared plus x plus 12. Additionally, include work to prove why any of the answers do not match. Well, I think probably the easiest way to do this is just to multiply each of these out. So I'm just going to color code each one so we can follow along. We're going to quickly multiply, and I'll show you a bunch of different methods to multiply these two, and you can be good from there. So we'll start with the first one, x minus 4 times x plus 3, and we'll do our traditional box method. Why not? Right? So here's our box, remembering to leave enough space on the side and on the top. X squared, 3x, negative 4x, negative 12, multiplying to find the inside. X squared, the like terms I circled, negative 4 and a positive 3 give us negative 1x minus 12. Does this match what we got? Oh, I don't think it does. Right, this x squared would have had to be negative to match, so I probably could have stopped right after that. But yeah, this one does not match, so 1 is out. All right, what about 2 and 3? Well, to save a little space here for 2 and 3, I'm going to use the arrow method or the distributive property. So we need to do negative x times 3, that's negative 3x. Negative x times a positive x, negative times a positive is a negative, and the way we show x times x is we write x squared. 4 times 3 is 12, and 4 times x is 4x. Kind of weird that this is out of order. Let's put the negative x squared first. Combine your like terms. I see positive 4 minus 3, which is 1x, and then positive 12. Does that match? Well, I think it does. Notice I wrote a 1 on this x. There's no 1 here, but you could always put invisible 1s in. And yeah, so it looks like 2 is good. I'll put a little smiley face next to it. What about 3? Well, same idea. X minus 4 times negative x minus 3. Distribute. Negative x squared minus 3x. Negative times a negative is a positive, and a positive at the end as well. Combine those like terms. Positive 1x plus 12. Looking good so far. It looked like 3 worked as well. Now 4 is a little bit strange, so I'm going to kind of block this off over here. Problem 4 has that extra negative out front, which is kind of tricky, and there's a few ways you can do this. I'll give you all 3 options, then you can choose your favorite. We should definitely remember that negative is really an invisible negative 1. Now, one option is right away you could distribute the negative 1, because you're like, I don't like having that out there, I just want these 2 binomials. But the question always comes up, well, wait, does the negative 1 distribute here and over here? Well, don't forget that these are all really just standing in for numbers eventually. So we have one number times another number times a third one. So if I asked you to do negative 1 times 4 times 3, do I do negative 1 times both of those? Well, no. When you multiply, you just multiply straight across and then just continue multiplying from there. And so it's the same here. This negative 1 doesn't multiply times the first set and the second set. The negative 1 either distributes into the first set to give us negative 1x plus 4 times x plus 3, or if you wanted, you could distribute it just into the second set. That'd leave the x minus 4 alone and give you negative 1x minus 3, and that'd be fine too. Or if you wanted, you could do all the multiplication here first, get one big answer to whatever you get, and then at the very end, multiply everything by the negative 1 on the outside. Any of those work, but because I wrote this one first, we might as well work this one out. I can switch back to the box here just because I have enough room. Negative 1x with a positive 4, x and a positive 3, and we multiply to find the inside of the box. Negative 1x squared, negative 3x, 4x, and 12. And when we combine those like terms on the diagonal, we find that this does indeed match the answer they asked us for. So it looks to me like we have 3 different options that all match that negative x squared plus x plus 12. All right, we are done with the first 5. It's about a third of the way through. Let's look at our next set. What is the simplified form of b minus 3 squared? Write your answer in standard form, and please don't kill puppies. Just a small, easy request. Well, standard form doesn't have the parentheses like this, so we probably need a way to get rid of the parentheses. I did mention not killing those puppies, and the way the puppies are no longer alive is when you take a power and distribute the power to addition and subtraction. That is bad. We don't do that. The only ways we really know to drop parentheses are if there's a number out front and no exponent we're allowed to distribute. Or we have to do what the exponent tells us. So we're not going to do that. Instead, we need to remember that a square means it's something times itself twice, right? There are 2 of the same factor here. That's why there's a square. We know how to multiply that out. We actually just spent quite a bunch of time multiplying that out. I'll do it in a box over here. We know we have a b minus 3 times another b minus 3. So it looks like it's b squared minus 3b minus 3b multiplying gives us a positive 9. So b squared minus 3b minus another one with a positive 9. I think if we combine like terms, negative 3 of something minus 3 more gives us negative 6 of those. And we're done. So really the trick with a square or a cube or anything is we just multiply that thing by itself instead of distributing. Let's try another one. What's the simplified form of negative 2a plus 3 squared? Well, we just practiced that. We know that that means negative 2a plus 3 times itself. Now you could do this in a box, but since I just did a box on the previous one, I might as well multiply. Negative 2a times negative 2a. Well, a negative times a negative is a positive, and a times itself is written as a squared. Next one, negative 2a times 3 is negative 6a. 3 times negative 2 is negative 6a. And 3 times itself is 9. Combining all those friendly like terms together, the 4a squared isn't going anywhere, but negative 6 minus 6 more of something is negative 12. And then the positive 9 just tags along to hang out with his friends. There we go. How about another? Find the equivalent form of negative 2 times c plus 4 squared. Justify your answer with work. Well, looking at these 4 answers down here, I don't see any of them with parentheses, which means they seem to have gotten rid of parentheses. Now, you might be tempted to say, oh, this is negative 2 times c plus 4 squared. I should distribute the negative 2. But that's a no-no. Then you wouldn't be following PEMDAS. PEMDAS says when you're multiplying everything out, when you're simplifying down, you must deal with the exponent before multiplication. And distributive property is multiplication. So we cannot distribute that negative 2 until we find a way to deal with the exponent. But we know how to deal with the exponent. We've practiced that a bunch. The exponent of 2, or the square, means we have to write c plus 4 times itself twice. The 2 is not attached to this 2 over here. This square is only attached to the c plus 4. So once I write c plus 4 twice, then we get a problem pretty similar to number 4, where we had all the different options. And so what do we do here? Well, you could either distribute the negative 2 to both of these, or distribute it over here, or, and I'm going to pick the third option here, I'm going to go ahead and work out the inside and then do the negative 2 at the end. So I'm going to multiply c times c, that's c squared, 4c, another 4c, and then 4 times 4 is 16. Any like terms that you guys see there? Oh yeah, I think so. We have this c squared, no like terms with it, but 4c and 4 more c's I think give us 8 c's plus 16. Well, last but not least, could we distribute the negative 2? Well, sure. There's no exponent up here preventing us from distributing, so now we're allowed to. Gives us negative 2c squared minus 16c minus 32. And we can see that the correct answer is D. This concludes the first half of your test. So if you're feeling pretty confident, if you're like, I can multiply, I can add and subtract, that's all you need to do on the first half of your test, and you are going to crush it. The second half of our test is the factoring portion. Now, factoring really is kind of like dividing these polynomials, which makes sense. We added, subtracted, multiplied. We kind of finished with division. It's not really division, but either way, there is a bunch of division involved. The one thing you're going to want to include, though, is that golden factor sheet that we've discussed before, the sheet that lists all your factors from 1 to 100, just to make sure that you are ready to be able to tell me what, let's say, all the factors of 72 are, or all the factors of 64. So make sure you have that handy, and once you do, unpause, and we'll start going through the rest of these problems. Alright, now that you have that factoring sheet ready to go, let's take a look at our next unit, factoring and solving factorable quadratic polynomials. And we'll start with problem 9. Mrs. Sanchez, Mr. Heizenrader, and Ms. Carrick all attempt to factor out the greatest common factor from the binomial 27x cubed minus 63x, whose work shows the fully factored form of the binomial. And how do you know? Well, let's look at each of their works. Well, first, it looks like Mrs. Sanchez looked at 27x cubed and let's do some different color and 63x and said, okay, well, the greatest common factor I see there is 9. And if you check, 9 times 3x cubed, 9 times 3 is 27. 9 times negative 7 is negative 63. That looks good, right? Maybe she found that by looking at the numbers 27 and 63, and I'll show you on the factor sheet, right? We have 27. There's only 4 of those, 1, 3, 9, 27, and 63. So it's 1, 3, 9, and 27 for 21. And she compared them, and she said, well, they both have a 1 in common. They both have a 3 in common. They both have a 9 in common. They don't have 27, though, so the largest factor that they have in common is 9. That's how she knew to factor out a 9 there. So she certainly took out part of the greatest common factor. That looks pretty good. Okay, let's come back to her later on. Let's look at Mr. Heizenreiter. Mr. Heizenreiter factored out a 9, just like Mrs. Sanchez, but he also factored out an x. Is he allowed to do that? Well, it looks like these each have an x in common. This one has, if I write it out, x cubed, which is x times x times x, and 63 just has a single x, but they do each have an x in common, and so we can factor that x out. Very nice, Mr. Heizenreiter. Miss Carrick looks like she also realized that we could factor out an x, but she only took out a 3. Is she allowed to take out a 3? Well, 3 times 9 is 27, and 3 times 21 is 63. Yeah, I think she can factor out a 3. So in fact, all of them did their factoring correctly. But who met the requirements of the problem? Who factored out the greatest common factor? Well, I would say that 9 is certainly greater than 3. So I think Miss Carrick is out. She didn't take out a large enough value from each of those. But then Mr. Heizenreiter also found that they two terms had x in common, and Mrs. Sanchez missed that x. So I think Mr. Heizenreiter got our correct answer. He factored out the largest common factor of 27 and 63, and factored out an x cubed and an x. And if you look at 3x squared and 7, you'll notice that they don't have anything left in common that we can factor or undistribute or divide out. So, Mr. Heizenreiter for the win. Alright, problem 10. Solve 4x squared minus 18x equals 0. Choose only a single answer choice, which should list all the solutions. Well, let's solve. I think, and we'll come back to this a few times, whenever we're solving these polynomials in standard form, there's always really 3 steps to it. The first step is make sure that your equation equals 0. Well, my equation does equal 0. That's very exciting. The second step is we need to put the equation in factored form using the box. And the bell's ringing because I'm recording at school. And then last but not least is we'll need to use the zero product property to solve. Alright, well this equation's already equal to 0, so we're done with step 1. I think we need to factor using the box. So when I factor using the box, we'll just build this guy over here. There are only 2 terms, and now we're working inside the box. When we put something in factored form, factors are like the outside of the box. These are the factors. So the inside has got to be the 4x squared and the minus 18x. And if there's only 2 terms like this, it should be pretty easy to put these inside. Then we factor out the greatest common factor. Now when we're doing this, we need to make sure that these 2 corner boxes always have a variable. They always have an x. So the first thing I'd look at is say, well, do these 2 have an x in common? They do. I can factor out an x from each of these. Phew! But do they have anything else? Well, 4 and 18. If I jump down here, we're looking at 4 and, I can fit them both on the same screen, 18. Cool. Well, they each have a 1 in common. The next largest I see is 2. They do each have a 2 in common. Do they have a 4? No, 4 doesn't go into 18. So I think the largest common factor here is 2. That was the largest number they both had in common. So I need to also factor out a 2. Once you've done the greatest common factor one way, the rest become much easier. The rest is multiplication. 2x times what is 4x squared? Well, 2 times 2 is 4, and x times another x is x squared, right? 2x times 2x is 4x squared. 2x times what is negative 18x? Well, 2x times negative 9 is negative 18x. And so now we have factored using the box. What have we actually done? Well, we took 4x squared minus 18x equals 0, and now we are able to rewrite that in factored form. In particular, 2x is multiplying times 2x minus 9. Well, what's our third step? Zero product property to solve. You guys remember what that is? Our zero product property tells us if we have factors that are multiplying to equal 0, we can make smaller equations, easier to solve equations, where each smaller equation or each factor is just set equal to the 0. So either 2x equals 0 or 2x minus 9 equals 0. Do you see I just took each factor, each outside piece of the box, and set them equal to 0? And now we solve. Divide both sides by 2. X is 0. Add 9 to each side. 2x equals 9. Divide by 2. And so we find that x equals 9/2. Notice that there are two answers, so we need an answer choice with two answers, and it looks to me like that is C. We have 0 and we have 9/2. These GCF factoring problems can be a little tricky, but you'll find that that factoring sheet will help you. Don't forget these 3 steps, write them down, make sure you have them handy, and you'll be just fine. Alright, 7.5. This is going to be our last lesson that we're going to focus on. It's factoring trinomials using a box. Alright, probably should say factoring and solving because we'll do that shortly, but here we go. The polynomial x squared plus 7x plus 12 is factorable. Now if something's factorable, that means we are able to take a box. There are 3 terms here, and we need to remember that 3 terms will always be split into 4 pieces in our box, x squared, 12, and then this 7x is what gets split up on the inside. If one factor is x plus 3, what's the other factor? Now, this one you might say, oh, this is going to be pretty tough. We have to do what adds, what multiplies, but this one's actually even easier. Because if we know one factor is x plus 3, factors go on the outside, x plus 3, you can actually figure out the rest of this pretty easily, right? X times what is x squared? Oh, x times x is x squared. X times what is this blank? Well, I don't know, it's blank. But 3 times what is 12? Oh, 3 times 4 is 12. And that's it. We found the other factor. Now, could you fill in the inside of the box? Sure, you don't need to. X times 4 is 4x. X times 3 is 3x. It's a nice way to check. If you combine 3x and 4x, is it 7x? Sure. If you multiply 3x times 4x, is it the same as 12 times x squared? Sure. But we only needed the other factor, because when they say something is factorable, they mean you can take this, the inside of the box, and you can rewrite it as the 2 factors on the outside of the box, x plus 3 and x plus 4. My other factor is x plus 4. Which answer choice below shows one of the 2 factors of the fully factored form, 8x squared plus 10x minus 3? Well, we should probably fully factor this one. Let's go through the actual steps. So we have our, and I'll use this side. I don't know why I keep using the other side. So we have our box. We know, oh, that's why I keep using the other side. I want the left side. Okay, there we go. We have our box. We know that 8x squared and negative 3 go in. But the problem is that 10x, oh, we need to split it up. So I know that 2 terms will add up to equal that 10x. The inside of the box needs to add to equal to 10. But the other trick that we've learned is that those same 2 numbers also need to multiply to equal something. What do they multiply to equal? Well, they multiply to equal the first term times the last term. 8x squared times negative 3 is negative 24x squared. Another way you could do that is multiply this diagonal to find the guy over there. Alright, what adds, what multiplies, which one do we start with? Well, we always start with multiplication. There's a limited number of factors. Remember that 10 though. So I'm going to jump down to my multiplication chart over to 24, and let's look at those factors. Okay, so 24, I always like to do my add and subtract. 24 plus 1 is 25. 24 minus 1 is 23. Neither of those are 10, so that's out. 12 minus 2 is 10. That's a possibility. 12 plus 2 is 14. 3 plus 8 is 11. 8 minus 3 is 5. That's out. 4 plus 6 is 10, and 6 minus 4 is 2. There's two options here. It's always trickier when that happens. Let's remember both of those. 2 and 12, 4 and 6. And I'll show them both. So we could have 2x and 12x, or we could have, and I'll show this up above here, we could also have what plus what is 10x, what times what is negative 24x squared. We could also have 4x and 6x. The question becomes, which one? Well, we can go through and start working with the negative. We know if these multiply to equal a negative, one of these has to be a negative, right? Let's pretend the negative's on the 4. Is 6 minus 4 equal to 10? No, it doesn't work. Okay, let's try it the other way. Is 4 plus negative 6, is 4 minus 6 equal to 10? No, that didn't work either. There has to be a negative 1, 1 to get the multiplication, but when we put the negative on one of them, it doesn't add to equal 10. It can't be these. So let's cross our fingers and hope it's the ones in green. Same thing, we need a negative. Let's try putting it on the 12 first. Is 2 minus 12 equal to 10? No, 2 minus 12 is equal to negative 10. It's pretty close though. Let's try the other one. Is 12 minus 2 equal to 10? Yes, I think we finally found it. It has to be 12x and negative 2x. Now let's find the outsides. Greatest common factor time. Okay, what do 8x squared and negative 2x have in common? Well, both an x. These ones will always have an x this year. 2 and 8, well, 2 doesn't have very many factors. The only things that multiply to equal to 2 are 1, which they both have in common, and 2. And I think 8 can be divided by 2 as well, so that's got to be a 2x. 2 times what is 8? 2 times 4 is 8. Coincidentally, if you look at your paper, 8 and 12 both have a 4 in common as a factor. 2x times negative 1 is negative 2x, 4x times 3, and so we found our factored form. 2x with a positive 3, 4x with a negative 1. Ha! Which of those factors? It shows up down here. It's 4x plus 1, 2x plus 3. There it is. It's got to be A. Alright, now that I'm pretty comfortable with you guys factoring, let's try solving. Solve this polynomial equal to 0. Well, don't forget your 3 steps. I'll write them along the top again. Right? We need to make sure that the equation equals 0. That it already does. The second one is we have to put it in factored form, so that's going to be the box. And last but not least, we also need to use that zero product property to make smaller equations. So let's start with the box. Okay. We know that what goes where? Well, x squared goes up front, negative 36 goes at the end. We need to split up negative 5x. What plus what is negative 5x? That's not enough room. There we go. Also, what times what equals, and this is our shortcut, x squared times negative 36. Maybe it helps you to put a 1 here. 1 times negative 36 is negative 36x squared. Let's go ahead and find 36 and see which ones add or subtract to make 5. So 36, there we go. There's no way this one's making 5, right? That's 37 if you add or 35 if you subtract. This is 20 or 16. This is 15 if you add or 9 if you subtract. Still none of those have made 5. 4 and 9 is 13, but 9 minus 4 is 5. That looks good. And 6 and 6 is 12. If you subtract, you get 0. Ha! Has to be 4 and 9. Only one possibility this time. It's going to go a little faster. So we know it's going to be 4x and 9x. The question is there a negative? Well, 4 times 9 is positive. It needs to be a negative. Yes, one of them has to be a negative. Will it be 4 minus 9 or 9 minus 4? Well, 9 minus 4 is positive 5. I think it's 4 minus 9. So 4x, negative 9x. Remember, it doesn't matter what order you put them in the box though. And last but not least, we factor. X squared, well, that's easy. They just each have an x in common over here. So we know it's an x and an x. X times x is x squared, x times negative 9, x times 4. Bonus box, 4 times negative 9, that is negative 36. We have now finished factoring using the box. So as a reminder, we had x squared minus 5x minus 36 equal to 0. By factoring, we're able to rewrite the equation as x minus 9 times x plus 4 equal to 0. We're on to that zero product property. Well, that, and I'll do it in green just so you can see what's happening, is when we split this into two separate equations. X minus 9 equals 0, or x plus 4 equals 0. We solve each equation, add 9, hooray, subtract 4. Awesome. We are doing wonderfully. Looks like we found two answers, positive 9, negative 4. That has to be B. Last page. Let's see what you guys can do. You really should be able to solve the rest of these now. However, if you do need the help, you can always let me guide you through it. But you should try it on your own and then see if you're right. Alrighty, hopefully you guys got a good chance to try 14, 15, and 16. If you got stuck anywhere, you can always fast forward to where you got stuck. Watch this on 2 times speed, or if you just were really stuck and you want to work through it with me, let's rock and roll. We're asked to solve this equation. We're keeping in mind those 3 steps, equation equal to 0, factor, and zero product property. Because your teacher is a nice human, certainly couldn't be me, they let you know that 2x plus 1 is a factor of this. How does that help us? Well, we have the equation 2x squared minus 7x minus 4 equals 0. Already equals 0, excellent. The second step then is we need to put this into factored form using the box. But we already know one factor. We know one factor is 2x plus 1. I'll do that in a different color. We know one factor is 2x plus 1. Unfortunately, though, we don't know the other one. But we have our wonderful box method, and if you know one factor, finding the other factor is pretty darn easy. We know this is 2x squared, this is negative 4, and 2x plus 1, either the top or the side, doesn't matter. We can just play the guessing game to find the rest of this. 2x times what is 2x squared? Well, we just need another x. X times x is x squared. 2x times what is blank? Oh, that doesn't help. 1 times what is negative 4, though? Isn't 1 times negative 4 negative 4? And look, just by knowing that information, now I know the other factor. How exciting! All right, well, at this point, we can go through and skip to step 3, the zero product property. We set 2x plus 1, the first factor, equal to 0. We also set x minus 4, the second factor, equal to 0. And then we solve each one. Add 4 on each side to get x equals 4. Subtract 1 to each side to get 2x equals negative 1. Our last step is dividing both sides by 2. And I find a lot of students look at this and say, negative 1 divided by 2. Is that negative 2? 2? What is it? Well, what I do is I just cover everything up except for the 1/2. I did that extremely poorly. Cover everything up except for the 1/2 that's right here and say, how would you say that? Most of them say, oh, that's the fraction negative 1/2. You're right, that's your answer. The answer is the fraction negative 1/2. So that's nice. That's one of our nice algebra tricks. If we get a fraction as an answer like this, just leave it as the fraction. Sometimes students will say, well, can I divide negative 1 by 2 and get negative 0.5? Sure. That works as well. It's just a little faster to keep it as a fraction. I boxed my answers so that we can see the answers. If you wanted, you could also write it in those cool curly braces. We usually put the negative answer first, least to greatest. That's just another way to say these two answers. All right, let's try 15. Solve the following equation. They even listed the 3 steps for us. How generous. Okay, well, we do need to make sure the equation's equal to 0. And right now I don't see it equal to 0. In fact, I see this equation equal to some expression on the other side. And so I'm going to put in the invisible 1 that's here and start moving everything to one side. Well, what side? It actually doesn't matter. I usually try to clean up the side with fewer terms. There's only 2 terms over here, so I'm going to get rid of or cancel all those out. How do I do it? Well, we undo the positive 1x squared by subtracting, right? Adding and subtracting cancels out to 0, so that's why I'm doing subtraction. And we do it from its like term. Because we're efficient, I'm also going to go through and subtract 1 from each side. Where on the other side? Over here. And we do that because 1 minus 1 is 0, 1x squared minus itself is 0, and so since there's nothing left, we just get to put 0 as a placeholder. What's on the right side? Oh, 4x squared plus 11x minus 3, negative 2 minus 1. All right, that's the first step. Write your equation equal to 0. Second step, we have to factor. When we factor, we put the 4x squared and the negative 3 in, and then we need to find two numbers that add to equal the 11x that we want to split up, and two numbers that multiply to equal the first times the last. And the first times the last, negative 12x squared. Let's look for factors of negative 12 that add to 11. Here's 12. This adds to 13 and 11. That's a possibility. That adds to 8, subtracts to 4, 7 and 1. Ha! It's got to be 1 and 12. There's only one option this time. Excellent. 1x and 12x. Now, unfortunately, 1 plus 12 is not 11. We also know that positive times a positive is not a negative. One of these has to be a negative. I'm pretty confident the 1 has to be a negative. 12 minus 1 gives us 11. So the correct way to split up 11x is 12x and negative 1x. Let's find the outside pieces. 4x squared and 12x each have an x in common. Both of these will. But I think 4 and 12 also have a 4 in common. 4x times x is 4x squared. I don't think we need to do anything else there. 4x times 3 is 12x. X times negative 1 is negative x. Bonus box, is negative 1 times 3 negative 3? I think it is. So what have we done? Well, we had 4x squared plus 11x minus 3 equals to 0. And now we've been able to rewrite this in factored form. Now we know that 4x minus 1 times x with a positive 3 equals 0. Once we're here, zero product property time. 4x minus 1 equals 0, or x plus 3 equals 0, and we start solving. Subtracting 3 from each side solves the second equation easily. We do need to add 1 to each side, and then divide both sides by 4, and we have our fraction 1/4, or 0.25 if you prefer. If you wanted to write those both together, negative 3 and 1/4. All right, last but not least, this is a very common question. I see it on the SAT, ACT, even sometimes on your semester final. The question is, what is the sum of the solutions in this equation? Well, if they're asking for the solutions, I think the first thing we need to do is solve this equation. It says quadratic. It's the same steps up above. Equal to 0, factor, find both solutions. Once we find the solutions, though, we have to add those solutions together because they asked for the sum, right? And a sum is addition of two or more numbers. So let's begin. X squared plus 1x equals 72 needs to be equal to 0 to start, so we will subtract our 72. There's no like term for 72 over here. Those ones have x's. So that's actually nice. It means less math for us. We just put the x squared standard form plus 1x and the minus 72 at the end. All right, let's use that box. X squared, negative 72. How do we split up 1x though? There's so many ways to do it. Well, we know that the two terms here better add up to equal 1x, but they also need to multiply to equal first times last, negative 72x squared. Let's look at 72. We're trying to make 1. I think 72 has lots of factors. If I remember correctly, it does. These won't make 1. No way, no way, no way, no way. I think these will make 1. If you add them, it's 17, but I noticed 8 and 9 were 1 apart, so we were able to simplify that down pretty quickly. So yeah, I think 8 and 9 are going to be our values here. 8x and 9x. Unfortunately, a positive times a positive isn't a negative. One of them has to be negative, but to get 1x, I think that's going to be on the 8. 9 minus 8 is 1. Alright, so we have 9x, negative 8x, or the other order. It's always nice when there's x squared here, because the only thing these terms will have in common are x and x. Easy every time there. X times what is 9x? 9. X times what is 8x? Negative 8. Cool. So what did we do? Well, we were able to write x squared plus 1x minus 72 equal to 0 in factored form, still equal to 0. X minus 8 times x plus 9. Zero product property time. X minus 8 equals 0, or x plus 9 equals 0. And let's solve. Add 8 to each side. Subtract 9 from each side. Whew. Now I boxed those, but did I get the right answer? Uh-oh. Well, the answers are the sum is 9. There's only one number in each of these answers. Oh, that's right, because to find the final answer, we have to sum our solutions together. So instead of boxing these, I need to take my two solutions, which are 8 and negative 9, and we need to sum or add them together. 8 plus negative 9, that's 8 minus 9, which is negative 1. At this point, you should really be a master at factoring and starting to feel comfortable on the rest of the problems. You will want to look back through your notes 7.1 through 7.5 and make sure that you're ready for your test coming up later this week. But thank you for hanging out with me. Hopefully you learned something and hopefully you're feeling confident. Good luck, rock stars. I have faith in ya.